20 trillion gallons. That's not a typo, and it's not an exaggeration for a thumbnail. That is a real, documented number of gallons of water that fell on the state of California in a single stretch of weeks. It was delivered by a chain of storms so relentless that meteorologists ran out of ordinary language to describe them. They reached for a phrase that's now permanently attached to California's weather history: an atmospheric river siege. I want to walk you through exactly what that number actually means, how a river can exist floating in the sky above an ocean, and why California's own state fire and weather agencies just quietly published a forecast flagging that a pattern very much like this one is considered likely again this coming fall and winter. This isn't a story about water falling on California today. It's a story about a number so large it's almost impossible to picture what it actually did the last time it happened. And why the people whose job it is to plan for the next one are already watching the sky. Stick with me to the end, because I'll show you exactly how meteorologists arrive at a number like 20 trillion, and why it's not the wild guess it sounds like. And if you want to be here when this pattern starts building again, subscribe before we get into it. Let's go. Let me start with the number itself, because before we talk about what it does, I want you to actually understand what 20 trillion gallons of water even is. On its own, it's just too big a number for a human brain to process. Most of us have never had to hold a number that size in our heads for anything real. We use trillion casually when we talk about national budgets or the size of tech companies, but we rarely stop to ask what a trillion of something physical actually looks like sitting in front of us. Water makes that easier than almost anything else, because water is something we interact with every single day in small, human-sized amounts. A glass, a bathtub, a swimming pool. So let's build the picture in stages instead of just throwing the number at you and moving on. Picture a flat surface exactly the size of the entire state of California, all 163,000 square miles of it. Mountains, valleys, deserts, coastline, everything. Now imagine covering that entire surface in more than half a foot of standing water, all at once. Not rain falling and draining away as it goes, standing water sitting on top of the entire state, from the Oregon border down to the Mexican border, from the Pacific coastline all the way out past the Sierra Nevada into the desert basins on the far side. That's the volume we're talking about. That's what 20 plus trillion gallons actually looks like when you stop treating it as an abstract statistic and start treating it as a physical quantity of water that has to go somewhere. During a run of storms in early January 2023, an atmospheric science student at UC Davis ran the actual math using rainfall totals from the National Weather Prediction Center. This wasn't a back-of-the-napkin guess done for internet clout. It used a standard hydrology conversion, the kind water engineers and reservoir managers use constantly, where a single inch of rainfall over 1 acre equals about 27,154 gallons of water. That conversion is not controversial. It is the same math used to calculate irrigation needs, reservoir inflow, and flood risk models across the entire western United States. Multiply that out across California's roughly 61 inches of statewide average rainfall over those weeks across every acre in the state, and you land on a genuinely staggering figure. Somewhere between 22 and 25 trillion gallons of water delivered to a single state in about 16 days. California's own governor cited an extremely similar number, telling reporters the state had received between 22 and 25 trillion gallons of rain since that storm sequence began. And he wasn't speaking in hypotheticals or reaching for a dramatic soundbite. He was standing in front of a state that had just been hit by 9 separate atmospheric rivers back to back, with federal disaster declarations already being issued for multiple counties. When the person in charge of managing a state's emergency response is citing a number that large in a press conference, it's not marketing language. It's the number his own emergency management agencies were working off of to decide where to send resources. So now let's talk about the actual mechanism, because atmospheric river sounds like a poetic exaggeration, and I want you to understand it's the opposite. It's a precise, technical, measurable phenomenon that meteorologists have been studying and refining their understanding of for decades. And once you understand how it works, the 20 trillion gallon number stops sounding impossible and starts making complete sense, because you start to see it's not some freak anomaly, but the predictable output of a well-understood physical process running at an unusually intense and unusually repetitive scale. An atmospheric river is a long, narrow corridor of concentrated water vapor flowing through the sky, typically stretching from the tropics out toward the coast, carrying enormous quantities of moisture at relatively low altitude. Think of it less like a cloud and more like an actual current, a ribbon of humid air thousands of miles long, but often only a few hundred miles wide, moving with real direction and real force, the way a jet stream does, except instead of carrying wind, it's carrying water in vapor form. According to NOAA, A single strong atmospheric river event can transport an amount of water vapor roughly equivalent to the average flow of water at the mouth of the Mississippi River, one of the largest rivers on the entire planet. Except this one is invisible, moving through the atmosphere instead of a riverbed, right up until it slams into the coastal mountains of California. And the moisture has nowhere left to go but down. When that plume of moisture hits the Sierra Nevada or the coast ranges and gets forced upward, it cools rapidly and all that suspended water vapor condenses and falls as rain, or at higher elevations as snow, in enormous, sustained quantities. This is the same basic physical principle behind why mountain regions are generally wetter than flat lowland regions downwind of an ocean. The mountains force air upward, the air cools, and the moisture it was carrying has to come out. Atmospheric rivers simply supercharge that process because of how much moisture they're carrying in the first place. Meteorologists actually grade these events on a numbered intensity scale, similar in spirit to how hurricanes get categorized. That scale ranges from a weak AR1 up through an extreme AR5, based on both the intensity of the moisture transport and how long the event lasts over a given location. An AR1 might bring a beneficial soaking to a drought-stressed region. An AR5, by contrast, is capable of producing hazardous, potentially destructive flooding on its own without any help from other storms. Here's what made the January 2023 sequence so exceptional, and why the 20 trillion gallon figure became the number everyone remembers from it. It wasn't one atmospheric river. It was 9, arriving back to back to back over less than a month. Each one added to ground that hadn't had time to dry out or drain from the last one. California's governor described it at the time as stacking, the likes of which the state hadn't experienced in living memory. He said it during the middle of what turned out to be an 8th storm in the sequence, with a 9th still on the way. Meteorologists watching the pattern in real time described a genuine sense of disbelief as forecast models kept showing yet another moisture plume queued up in the Pacific, arriving almost as soon as the last one cleared out. That stacking effect is the real story behind a number that large. Any single atmospheric river, even a strong one, might drop a few inches of rain over a few days. That alone is manageable for most watersheds. The ground absorbs what it can, rivers carry the rest to the ocean, reservoirs capture a portion, and within a few days, conditions largely normalize. 9 of them, one after another, with no recovery time in between, is a completely different situation. Soil that's already saturated can't absorb any more water, so each subsequent storm sends a larger and larger share of its rainfall directly into rivers and streams instead of into the ground. Reservoirs that are already near capacity have less room to safely hold the next pulse. Rivers that are already running high have less capacity to carry additional flow before they overtop their banks. That's what turns a normal wet season pattern into a historic, statewide 20 trillion gallon event. Not just the raw volume of water, but the complete lack of any recovery window between each delivery of it. I want to be honest about what that much water actually did to the state, because the number itself, however staggering, doesn't tell the whole story on its own, and I don't think it's responsible to talk about a number like this without being straightforward about the human cost behind it. The January 2023 sequence killed at least 18 people, according to California's Office of Emergency Services at the time. It caused roads to partially collapse. It flooded entire neighborhoods and forced thousands of people to evacuate, some with very little warning as levees and creek banks gave way faster than local emergency services could get ahead of. Entire communities in the Central Valley, an area historically prone to catastrophic flooding precisely because it sits in a low basin between 2 mountain ranges, saw water levels rise in ways some longtime residents said they'd never personally witnessed. And this is the part that I think deserves real emphasis, because it's the piece that gets lost in a headline chasing a big scary number. The same storms that killed people and destroyed property also, within weeks, pulled California almost entirely out of a drought emergency that had gripped the state for years. Before those storms hit, roughly 43% of California was classified under extreme or exceptional drought. The 2 most severe categories on the U de Westiu. Drought monitors scale, categories that typically mean widespread crop and pasture losses, water restrictions, and serious strain on reservoirs that millions of people and an enormous agricultural industry depend on. Within about 3 months, the U.S. Drought Monitor showed the state with no areas remaining in either of those categories at all. Not reduced, not improved, gone. The state's 2 largest reservoirs saw their combined storage increase by 66%, a shift that under normal circumstances would take multiple wet seasons to achieve gradually. 27 million people ended up receiving more water than they'd been allocated just a month earlier, as state water officials revised allocation numbers upward almost as fast as the storms were arriving. That's the genuinely strange, 2-sided nature of an atmospheric river siege. The same event can be simultaneously the most dangerous weather disaster a region has seen in years, and the thing that ends a multi-year drought almost overnight. It's not a contradiction. It's the same water arriving too fast in some places to be anything but destructive, and arriving in reservoirs and groundwater basins in other places as exactly the relief the state had been waiting years for. Now, here's why I'm bringing all of this up right now in the middle of August, when nothing like this is actually happening on the map today. Because California's own state fire and weather agencies just published their seasonal outlook for the months immediately ahead, and it's worth understanding what they're already flagging well before the season actually turns. The Southern Operations Seasonal Outlook, issued at the end of July and covering the period from August through November of this year, explicitly states that as the state transitions out of the dry season, conditions are expected to run warm, and that atmospheric rivers are considered likely as the wet season gets underway. That's not a dramatic prediction pulled from nowhere, and it's not the kind of thing published to generate headlines. It's the kind of routine, technical seasonal assessment that fire and water agencies produce every year to plan resource allocation, deciding where to preposition firefighting crews, how to plan reservoir releases ahead of incoming storm capacity, and how to brief emergency management officials across the state's dozens of counties. And this year's version specifically calls out the same phenomenon responsible for that 20 trillion gallon event back in January 2023. So let's talk about why forecasters are already thinking about this months in advance, because the reasoning connects directly back to the mechanism I explained earlier. Atmospheric rivers form when there is a strong, persistent plume of tropical or subtropical moisture connecting to a storm track that funnels it toward the California coast. The strength and frequency of that setup from year to year depends heavily on the broader state of the Pacific Ocean, including the kind of El Niño pattern that's been shaping this year's weather across multiple other systems. The same El Niño that's been suppressing Atlantic hurricane activity has real implications for the storm track that eventually determines how active California's atmospheric river season becomes once fall and winter arrive. These large-scale ocean patterns act almost like a steering wheel for where storm tracks tend to set up across an entire hemisphere, which is exactly why the same underlying Pacific signal can show up simultaneously in stories about hurricane activity in the Atlantic and storm activity thousands of miles away on the California coast. Forecasters watching sea surface temperature anomalies and the broader Pacific pattern right now are doing exactly what allowed them to see the January 2023 sequence coming with real lead time back in December 2022. They're reading the large-scale ocean and atmospheric setup for the signs that tend to precede an active, or even historically extreme, atmospheric river season. This is genuinely useful predictive work, even months out, because while it can't tell you exactly which week a specific storm will arrive, it can tell you with reasonable confidence whether the overall conditions this season favor an unusually active pattern versus a quiet one. I want to be careful here, in exactly the way I try to be careful with every story like this, because there's a meaningful difference between atmospheric rivers are likely this wet season, which is what the current outlook actually says, and a 20 trillion gallon mega event is confirmed to be coming, which it does not say. Every California wet season includes atmospheric rivers to some degree. They're not an anomaly. They're the primary mechanism by which the state receives the majority of its annual precipitation in a normal year. Without them, California simply doesn't get its water. What varies enormously from year to year is how many arrive, how intense each one is, and critically, whether they stack back to back the way they did in January 2023, without enough recovery time between events for the ground to drain and reservoirs to safely absorb the next pulse. That stacking behavior is genuinely difficult to forecast with high confidence more than a few weeks out, even when the broader seasonal outlook correctly identifies that conditions favor an active atmospheric river pattern overall. A seasonal outlook can tell you the field is fertile ground for a big event. It generally cannot tell you months ahead of time whether that big event will actually materialize, or whether the season will instead deliver its precipitation in a more spaced-out, manageable way. Here's the part of this story I think deserves the most attention because it connects everything back to what actually matters for people living in California right now, in August, with the wet season still months away. A 20 trillion gallon event isn't purely a weather story, it's a water management story, an infrastructure story. And in the years since 2023, it's become a genuine planning priority for the state. California has spent real effort since that historic storm sequence working on capturing more of that floodwater, rather than letting the majority of it simply run off to the ocean. That effort includes expanding groundwater recharge programs, where excess floodwater is deliberately diverted onto agricultural land and natural basins, specifically so it can soak into underground aquifers instead of racing out to sea. It includes revisiting operating rules for major reservoirs, some of which had historically been managed under flood control guidelines written decades ago, well before modern forecasting could give dam operators the kind of advanced notice they have today about incoming atmospheric river events. That's because the same state that watched 18 people die in flooding in January 2023 also watched a years-long drought emergency essentially end within the same 3-month window. And the lesson state water managers took from that whiplash is that both outcomes, catastrophic flooding and drought-ending relief, are often riding on the exact same storms. The difference between disaster and relief often comes down to timing, ground saturation, and how much of that water the state's reservoirs and groundwater basins are actually equipped to capture and hold, rather than let flood downstream unused. So where does that leave things right now? Honestly, California is currently in its dry season, the same dry season the state's own fire outlook describes as carrying near normal wildfire potential through the fall. There is no current atmospheric river event underway, and nothing resembling the 20 trillion gallon siege from January 2023 is on the map today. If you're checking a live radar or satellite loop right now looking for the next megastorm, you won't find one. That's exactly the point of walking through this now, rather than waiting for a storm to already be bearing down on the coast. What is true, and what the state's own forecasters are already on record about, is that as this dry season transitions into the wet season over the coming months, atmospheric rivers are considered a likely feature of that transition. That's shaped in part by the same Pacific Ocean patterns that have been driving weather stories across the country all year. Whether this coming season produces a routine, manageable series of storms or another historic stacking event like January 2023 is something that will become genuinely forecastable with real confidence only as we get closer to the season itself, typically within a lead time of 1 to 2 weeks once a specific atmospheric river event is actually forming. That's a meaningful gap between what a seasonal outlook can tell you and what a specific storm warning can tell you. And understanding that gap is exactly what separates a responsible breakdown of this story from a fear-driven one. Let me bring this back to something practical, because that's always the point of walking through a story like this instead of just repeating a scary number. If you live in California, this is a genuinely useful moment, and while the state is still in its dry season and before any specific storm is on the map, to actually think through your household's flood and storm preparedness, rather than waiting until an atmospheric river warning is already active and supplies are harder to find. That means knowing whether your home sits in a flood-prone area, which is often a matter of checking your specific address against publicly available FEMA flood maps, rather than assuming your general region is safe, just because it hasn't flooded in recent memory. It means understanding your property's specific landslide risk if you're anywhere near burn-scarred hillsides from recent wildfire seasons, since burned slopes lose the vegetation that normally holds soil in place during heavy rain, which is exactly why some of the deadliest debris flows in California history have happened, not during the fire itself, but during the first heavy rains afterward. And it means simply being aware that California's wet season, when it does arrive, has a well-documented history of swinging rapidly from drought relief to genuine emergency within the same sequence of storms, which means preparedness shouldn't be an either-or decision between planning for drought or planning for flooding. In California, increasingly, it has to be both at once. None of that requires believing a specific mega event is confirmed for this winter. It just requires taking the state's own seasonal outlook seriously, the same way you'd take a hurricane outlook seriously along the Gulf Coast without needing a specific storm on the map yet. Nobody along the Gulf Coast waits for a named storm to start checking their hurricane supplies every single year. They treat the season itself as the trigger for preparedness. The same logic applies here. Before you go, I want to ask you something, because I think California's atmospheric river story is one of the more genuinely fascinating examples of how the exact same weather event can be two completely different stories, depending on where you're standing. If you lived through the January 2023 storms, or if you remember hearing about them, does 20 trillion gallons register to you more as the disaster it caused or the drought relief it delivered? Drop a comment and tell me, because I think that split says a lot about how complicated it actually is to cover a story like this responsibly, instead of just picking the more dramatic half of it. If this gave you a clearer picture of what that number actually means and what's genuinely being watched for this coming season, hit that like button. It helps grounded, accurate breakdowns like this one reach people instead of recycled, scary headlines detached from what's actually happening on the calendar. Subscribe so you're here the moment this fall's wet season pattern actually starts to take shape, because I'll be tracking it from the very first system that develops. Drop your thoughts in the comments, and I'll see you in the next one.